for both SS1, SS2, and SS3 students. I welcome you all my participants. Today, let's study physics. Now remember, in our previous class, we talked about the crystal structures of matter. Under it, we talked about the crystalline solid and the amorphous solid. And we said that crystalline solid, that what differentiates it between the amorphous solid is that they have definite pattern of words, arrangements. We equally define crystal as a piece of solid matter in which the atoms, molecules, or ions are arranged in a highly regular repeating pattern, which we call the piece word lattice. Now remember these crystals we are talking about. You cannot see them with your naked eye. You can only see them using your X-ray diffraction or using your micrograph from electron ion microscope. So you don't see them with your naked eye. Equally, remember that we talked about the structures of simple crystals, which we said they are divided into three. How these crystals are being arranged, their structures. We have the simple cubic lattice, we have the face-centered cubic, we equally have the body-centered cubic. Now, today, we are going to look at photon. We are going to look at photons. Under it, we are going to look at the particle nature of what? Photons. Now, let's see the specific objectives. By the end of this lesson, my students will be able to, number one, define photon. Secondly, you'll be able to mention 4 particle properties of photon. Thirdly, you can say the particle nature of what? Photon. Then, fourthly and finally, you can use the concept of photon to explain that light behaves like what? Particles. Now, what is a photon? A photon is a packet of energy in the form of electromagnetic radiation. Photons, they are packets of what? Energy in the form of electromagnetic radiation. Remember, when you talk about electromagnetic radiation, there are those radiation that do not require material medium for their what? Propagation. Those radiation you get from your X-ray, from your ultraviolet rays, from visible lights and others. They don't need any material medium to be what? Propagated. For example, when you go for X-ray, maybe when you were about to enter secondary school, they required your X-ray. When you go there, you find out that light must be on, and they will ask you to stand. Before you know it, they will ask you to, assuming you want to take for that of heart, you will pull up your shirt. Now, after some minutes, you'll be told to go. Now, you find out that before you know it, they will print it out and give it to you. Now, what happened? The radiation has been transmitted through you. So they don't need any material medium for their propagation. That is the electromagnetic world radiation. And this photon we are talking about, they are packets of energy in form of electromagnetic world radiation. Now, you find out that in 1905, Einstein, a great scientist, extended an idea that was originated by what? Planck. It was Planck that started this electromagnetic radiation of photon, but it was now carried on by a scientist called who? Einstein. Now, electromagnetic radiation we are talking about can be emitted, it can be transmitted, it can be what? Absorbed in these discrete packets or quanta of energy, which we call what? Photon. Now remember, for example, if you are putting on a black clothes in a hot afternoon, you find out that you feel very, very what? Hot. What happens is as a result of electromagnetic radiation from the visible light from the sun, they have been transmitted through you and your body absorb it because you are wearing a black colored what? Clothes. So for example, if you're putting on a silver colored clothes or white clothes, when this radiation from sun visible light falls on you, it will be what? Emitted, or it will be thrown back. So this electromagnetic radiation, they can be transmitted, absorbed, or what? Emitted or reflected in form of this packet of energy we are talking about called what? Photon. Now remember, this photon, equally you cannot see them with your naked eye. They are very tiny what? Particles. Now let's see the diagram of this photon. Diagrammatic representation of photon. So this is how photon looks like. You can see the photon when it is being emitted or reflected or transmitted or absorbed. Look at the diagram of photon. They are very tiny. Now look at this photon also. Now we have what we call the energy levels of these electrons. This E1 is your first energy level. E2 is what? Second energy level. We equally have E0, which is the ground state. We are going to talk about this in proper when you're talking about quantum physics. Now you find out that these electrons, when they are being excited, they move from one energy level to another. For example, you excite them by making them to gain speed. You find out that this electron move from one energy level to another, and as they do so, photon is being emitted in form of electromagnetic radiation. So you can see your photon. And I said a beam of light is treated as a system of particles which are discrete energy called photon. And each photon travels with the speed of light. We'll still see that later. Now, let's look at the particle nature of what? Photon. Particle nature of what? Photon. Now, this electromagnetic radiation we are talking about, they can behave as waves. They can equally behave as what? Particles. And now we use photon to describe the particle nature of this electromagnetic radiation. Now you have the particle nature of what? Photon. Now the photon is an elementary particle, or a particle that cannot be split into what? Anything smaller. Just as you have your atom, the smallest particle of matter, the same way you have this photon. They are very, very tiny. You cannot see them with your naked eye. They carry electromagnetic force, which is one of the four fundamental forces of nature between particles. Now, electrically charged particles attract or repel each other by exchanging photon back or front. So, energy generated by moving charge is what? Electromagnetic radiation. Now, visible light is one kind of electromagnetic radiation. As I've mentioned it before, I mentioned the types of electromagnetic radiation, and one of them I mentioned it as the visible light. You have others. You have the radio waves, you have the infrared waves, and your X-ray. You have others. For example, your radio waves, you will be at your house and find out that you tune to different stations. So they are electromagnetic what? Radiations. They don't need material medium for their what? Propagation. Now the concept of photon is used by scientists to describe the effect of radiation when they behave as what? Particles. So I've told you that these radiations, they can behave in form of waves, they can behave in form of particles, but we use photon to explain the particle behavior of this radiation. Now look at this. You find out that most of these photons, they are invisible to human eye. you don't see some of them. Most of them, you don't see them. Human only see photon with energy level that fall within a certain range. There is a photon that we can see with our naked eye. It will have energy level E that falls at a certain range. And what is that photon? Visible photon. That is visible photon as visible light. So only photon from the visible light from the sun, that is the only visible photon, because they have a particular range of what? Energy level, which I've told you that you have the ground state E0, you have the E1, the first energy level, E2, the second energy level, E3, the third energy level. You see that better when we're talking about quantum physics. Now, invisible photon, they include others, your radio wave, radio and television signals, photon that heat food, that is from your microwave oven. That's your microwave, when you're using it to heat food, you are generating what? Photon. The ultraviolet lights, photon from ultraviolet light that causes your sunburn. You have that from your X-ray that doctors use to view a person's bone and others. Now let's look at the particle properties of what? Photon. Particle properties of photon. Now, according to photon theory of light, photon has the following particles. We are going to mention them and explain them. Number one, photon travel at the speed of light. And what is speed of light? Speed of light is constant. When we are talking about photon, we use speed of light as c. But when we are talking about others, velocity, we use it as v, velocity of light. So this speed of light has a constant value, 3.0 times 10 raised to power 8. Remember the unit. Speed is measured in meter per second. So this photon we are talking about, they travel at a very high speed, at a very high what? Speed, 3.0 times 10 raised to power what? 8. That is around 300 million meter per second. So in 300 million meter per second, in 1 second, this photon travel with the speed of 300 million meters in 1 second. You can find that they have a very high speed. Now the second particle properties of photon is that they have no or zero mass with no electrical charge or rest energy, and only object without mass can travel at that high speed of light. Object with mass must travel at speed faster than the speed of light. Now you find out that for object to travel to such a high speed of 3.0 times 10 raised power 8 meter in 1 second, that object must be very, very light. So another particle properties of this photon is that they have no or zero mass. Now let's see other properties. Okay, before then we continue with the explanation. You find out that photon, they do carry energy and momentum. That is another property, number 3. Photon do carry energy and momentum, which are related to the frequency and wavelengths of electromagnetic radiation. So photon, they do carry energy, which we say the energy of photon is equals to E. And when you're talking about the photon traveling from energy level 1, E1, to E2, when you want to find the energy level, the change in energy level, you say delta E will give you equals to E2 minus E1. That is when the energy level is from the second energy level to first energy level. Now the energy of photon E is equals to what? HF. E is talking about the energy of photon measured in joules. H is a constant which we call Planck's constant, which we call what? Planck's constant, from the name of the scientist Planck, who talked about this photon in quantum physics. Now, F is the frequency of this photon. Remember frequency, the number of vibration or oscillation the body moves in 1 second. So F is talking about the frequency of this photon. Now we said that the energy of photon is equal to the product of constant number called the Planck's constant, that is your what, h, multiplied by the frequency or number of vibration per second of the photon, and that is your F. Frequency is measured in hertz. Photon with high frequency like your X-ray, they carry more energy than photon with low frequency, such as your radio waves. So there are photons that have higher frequency than the others. For example, the photon of your X-ray, it has a higher frequency. That means it will have more energy than photon with low frequency. Like that of your radio wave, they will have low energy. Now, photons that are visible to the human eye, as I've said before, they have energy levels around what? Electron volts, and frequency from 10 raised to power 14 to 10 raised to power 15 watt hertz. I told you that photons that are visible to human eye, they will have a particular what? Frequency. And you can see it. For you to be able to see this photon, which is photons from visible eye, they have a particular what? Energy, and they have a particular what? Frequency, which is from 10 raised to power 14, very high, to 10 raised to power what? 15. Now, the frequency of visible photon corresponds to the color of their light. Remember these visible lights? We have many colors of visible lights. You have your red, the red color, orange. You have your green. You have your violet. You have your indigo and others. So we say that the frequency of this visible photon will correspond to the color of the light. Now, for example, photon of violet light. These visible light, colors from visible light, we call them Roy-Bev. R, red lights. O, orange. G, green, that is green color lights. Then you have others, that is that Roy-Bev. You have your V, violet. I, indigo, and others. So photon of violet light, which is the last one among them, have the highest what? Frequency of what? Violet light. While photon of red light, which is the first one, have lowest what? Frequency. Now, gamma ray is another electromagnetic radiation. The highest energy photon of all is from gamma ray. Gamma ray, which is one of the electromagnetic radiation, have the highest photon of all. Now, it has energy of around 1 gig electron volts. This is 1 gig electron volts, to the range of 10 raised to power 9 electron volts. And it equally have a higher frequency, which is greater than 10 raised to power 18 hertz. So you find out that the electromagnetic radiation, which is gamma rays, have the highest photon with energy level. It has the highest energy level of photon, and it equally have the highest what? Frequency, which we say it is higher than 10 raised to power what? 18 hertz. Now, another property of photon, photon can have particle-like what? Interaction. Remember, we say the particle nature of this radiation, we explain it using photon. So photon can have particle-like what? Interaction, that is collision with electrons and other particles. You can see that in quantum effect. We'll still talk about that. Now, another property is that photon can be destroyed or created when radiation is absorbed or emitted. Remember we said that these radiations, we can absorb them or emit them or transmit them in form of what? Photon. So this radiation, when they are being transmitted or emitted or absorbed, the photon you generate can be destroyed or it can be what? Created. Now, we're going to use the photon concept to explain the particle nature of light. Use of photon concepts to explain the particle nature of light. We want to use the photon concept to explain the particle nature of what? Light. Now we're going to explain this using number 1, photoelectric effect. Remember, we're talking about use of photon concept to explain the particle nature of what? Light. Number 1, we're going to explain this using what we call photoelectric effect. Now, most scientists, they did not pay attention to Planck's theory until in 1905, when the German-born American physicist called Albert Einstein used the idea of photon to explain an interaction he should studied called photoelectric what? Effects. Now, in this interaction, light shining on the surface of a metal causes the metal to emit what? Electrons. It causes the metals to emit what? Electrons. Now, electrons escape the metal by absorbing energy from the light. Now, Einstein showed that light behaves as particle in this situation. If the light behaved like wave, each electron would absorb many light waves and gain more energy and more energy. He found, however, that a more intensive beam of light with more energy instead, more light caused the metal to release more electrons, each of which had the same amount of energy. Now, what are we talking about? We are talking about the photoelectric effect. You want to use the concept of this photoelectric effect to explain what? To explain our particle properties of a photon. Now, you find out that this photoelectric effect, it is the emission of electron from a metal surface when electromagnetic radiation of sufficient high energy is incident on it. Now, you find out that when incident light of an appropriate frequency falls on a metal, electrons are being liberated in form of what? Photon. So you find out that this incident light, they must have appropriate what? Frequency, not any frequency. There is an appropriate frequency which this incident light, when they fall on a metal, electrons will be liberated from the surface of that metal in form of this electromagnetic radiation that we call what? Photon. Now we can equally explain this particle nature of photon using what we call the Compton effect. Using the Compton what? Effect. Now, the Compton effect is another phenomenon that demonstrates the particle nature of what? Photon, or electromagnetic radiation in particular. This effect was discovered by a scientist called A.H. Compton in 1923. Now, what did Compton do? What did he do? He scattered X-ray from various material, and he found out that the scattered light has slightly longer wavelength than the incident light. So in that case, there is a loss of energy in form of what? Photon. In form of what? Photon. Now let's see the diagram. Now you find out that what Compton did, here you have a target electron, there is an incident light, This incident light, when it hit this target electron, we have a scattered what? Electron. Some of the electrons or some of the lights were scattered, and you find out that there is loss of what? Energy. And you find out that this incident photon, they have longer wavelength than the scattered what? Photon. So this incident photon, when it hits this target, photon was scattered, as you can see. And this incident photon have longer wavelength. You can see the wavelength, longer wavelength than the scattered what? Photon. And that indicates that there is what? Loss of what? Energy in form of what? Photon. In form of what? Photon. Now we have other phenomena that can be used to explain the particle nature of light, which include the black body radiation, emission or absorption of light, momentum, and what? Energy. They equally explain the particle nature of what? Light. They equally explain the particle nature of light, apart from photoelectric effects and that of what? Compton effects. So photon is talking about, we use it to explain the particle property of electromagnetic radiation. We use it to show that this electromagnetic radiation can behave as what? Particle. And remember, I told you that this photon, you cannot see them with your naked eye, and that this electromagnetic radiation, they can be transmitted when they fall on a body, they can be emitted, that is reflected, or they can be absorbed in form of what? Photon. Now, you look at the assignment for today. Number 1 assignment says, what is photon? Number 2, state 4 particle properties of photon. And lastly, state 2 phenomena that explain the particle nature of photon, and explain one of them. Remember your assignments, you send it on my private page 0038272709 to avoid overflooding of our platform. Now, thank you once again, all my participants. Thank you for listening.